So before going to that, I heard and I had seen that in the previous video there was a lot of blurriness. So first of all, comment it and tell me that there is clarity, good clarity is there or not, or my voice is visible to you or not. Just do the comment. I'll see that. Then after I will move forward. I'm waiting for your response. Just comment it that clarity is there or not. Then after we'll move forward. Okay, come on. Because if clarity is not there, then how could I understand? I will waste my energy, I will waste a lot of time, network, all the things, and you will not be able to see that, you will not be able to understand. So do the comments so that I can understand. Okay, so just keep on commenting and after that I will see that. Okay, so here we have to start the second part of the second part of work, power and energy, and in that I have told you the introduction of work, power and energy. So I hope that all the points of introduction of work, power and energy will be understood to you. Second thing, here we'll have to start and here we'll have to understand the SI unit of work, power and energy separately. Okay, what is the difference between them, what is the relation between them, how do we get it? So all the things we have to include and all the things we have to understand in this. So let's begin with the first topic, that is work. What is the SI unit of work? Before that, first of all, what we have to understand what is the formula of work. So I've already told you on that day that the work done means force into displacement. Force into displacement. That means if we have applied force and if there is displacement, then we can understand there would be work done. So what is the SI unit of force? That is Newton. What is the SI unit of displacement? That is, what is that? Meter. Good. So the SI unit of displacement is meter and force is Newton. So that comes Newton meter, and that is also equivalent to Joule. Sorry, it is Joule. Okay, Joule, denoted as J. ये जूल है, जूली मत पढ़ना कोई. Okay, कि पता चला E है लास्ट में तो जूली. No, it is Joule. So the SI unit of force is, oh sorry, work done is, simply we can say it is Joule. Now it may be asked what is the definition of Joule, how can you understand Joule? So that for that we can say 1 Joule is equal to 1 Newton into 1 meter. This can be said, and that is the definition. For the definition you can say work done of 1 Joule is said to be done when 1 Newton of force is applied on any object and it have the displacement of 1 meter. What you can say? When there is 1 Newton force applied to an object for the displacement of 1 meter. For the displacement of 1 meter, it is said to be work done of कितना 1 Joule है ना गधों 1 Joule. It is said to be the work done of 1 Joule. So that is SI unit of Joule, sorry, SI unit of work done, and that is also the definition of 1 Joule. So if it is asking, you have to keep it in mind. The next thing that we have to understand is about energy. So let's see what is the SI unit of energy. So basically what we have studied yesterday, actually yesterday means the last working day on which we have study. So energy is equivalent to work. Energy is equivalent to work. And if energy is equivalent to work, that means the SI unit of energy will also be equivalent to joule. Both of them are having same SI unit. But what changes in energy, that the smallest unit of energy is erg. What is that? erg. ERG. दिस इज द स्मॉल. जैसे हम लोग डिस्टेंस में कहते हैं ना कि सबसे बड़ी यूनिट क्या होती है, किलोमीटर, देन मीटर. तो सबसे छोटी क्या आ जाती है हमारी, सेंटीमीटर. सो लाइक दैट जूल is the SI unit of energy, but if we are talking about the smallest unit than joule, that is erg, and 1 joule is equal to 10 raised to the power 7 erg. 10 raised to the power 7 erg. So these are the SI unit of energy and work. I hope these 2 points will be clear to all of you. If you are having any doubt, you can comment it. You can comment it in the comment box, and then I will understand and I will see if it is any point, any doubt, I will clear it. Then after we'll move to the third, that is power. Am I going very fast? If it is very fast, then you can also comment it. I will understand, and I try to reduce my velocity. Velocity हो गया, speed कुछ बताया था? पता नहीं क्या क्या बताते हैं सर, क्या क्या पूछते हैं. Power. I hope that I have told you the formula of power. What was that? The formula of power was work done and क्या था? Yes, correct. Work done upon time. पता नहीं किसने बोला या नहीं बोला, बट मैंने बोल दिया करेक्ट. जिसने बोला सही बोला, नहीं बोला तो नहीं बोला, तो समझो. Work done upon time. And what is the SI unit of work done? As I've told you, SI unit of work done is joule and time is second. So here we will get joule per second. And this joule per second is also written as watt. What is written as? Watt. This is the name of the scientist. What is the name of the full name of the scientist? James Watt. पढ़ा था इनके बारे में कुछ बनाया था इन्होंने, कोई डिस्कवरी कोई बता सकता है? बताएं क्या? He has made, नहीं बताएंगे, ढूंढ करके फिर बताओ. I'm not gonna tell you. इतनी मेहनत तो तुम्हें खुद से करनी पड़ेगी. Okay? So check it out. What he had made. I'll give you a hint. He has made an engine. कौन सा इंजन बनाया ये तुम लोग ढूंढो. Okay? So James Watt. Okay? So the SI unit of work is, power is watt. And again, if you want to write the definition, 1 watt is equal to 1 joule upon 1 second. So when the work, 1 joule of work is done in the time taken of 1 second, there would be 1 watt of power applied. You can write it. When 1 joule of work is done but in 1 second of time, या टाइम नहीं भी लो, 1 second, सीधा 1 second, it must acquire 1 watt, acquire power of 1 watt. Acquire the power of 1 watt. Okay? सही है? सब बोलोगे सही है. गधों. Here it is wrong. I've already told you that it is the name of a scientist, so his initial will always be capital. Okay? So that is 1 watt. Okay. After that there are some relation. अभी हमने एनर्जी में क्या पढ़ा था? छोटी यूनिट पढ़ा था. अब इसमें हम क्या करेंगे? बड़ी यूनिट पढ़ेंगे. Okay? So I'm going to erase this. this watt is having a higher unit called kilowatt. What is that called? Kilowatt. In kilowatt, actually it is having 1000 watt. How much? 1000 watt. अच्छा, कभी किसी घर में ट्रैक्टर है या जनरेटर, तो लोग पूछे ना, बताते होंगे, बात करते होंगे आपस में, कितने एचपी का इंजन है, हाउ मच एचपी इट इज हैविंग. So that HP is also the unit of power. That HP, that is also called 1 horsepower. Horsepower, and that is written as HP. So how much watt does 1 HP contains? Basically, it is not given in your book, but you can understand it. It's only one line sentence. So 1 horsepower contains 748 watt. ये छोटा क्या करते हैं सर? हमसे बोलते हैं कैपिटल लिखना, खुद स्मॉल लिख देते हैं. Okay, so 1 horsepower contains 748 watt. Then after, what we have to understand, 1 kilowatt is having 1000 watt, 1 horsepower is having 748 watt. Now what we have to understand, that is the types of work. Types of work. So there are basically 3 types of work. कितने? पर काम तो एक ही तरह का होता है, या तो करते हैं या तो नहीं करते हैं, बट साइंस में 3 तरह का होता है. Types of work. As I am explaining, जैसा जैसा बताते जा रहा हूँ वैसे ही नोट्स बनाते जाना कॉपी में. अगर समझना है, रिवीजन करना है तो, और नहीं करना है तो भाई तुम्हारी मर्जी, उसमें हम कुछ नहीं कर सकते, क्योंकि इम्पोर्टेंट तो हम बताने से रहे. सोचो, हमारे लिए सब कुछ इम्पोर्टेंट है. तो बेसिकली देयर आर 3 टाइप्स ऑफ वर्क. कौन कौन सा होता है सर जी, ये भी बता दीजिए. देखिए भाई, सबसे पहला होता है पॉजिटिव वर्क. ओके. सेकंड इज नेगेटिव वर्क. ओके. एंड थर्ड इज जीरो वर्क, मतलब काम ही नहीं किया. या तो देखो, या तो हम काम करते हैं पॉजिटिव, या तो नेगेटिव, या फिर जीरो. आइदर इफ वी आर डूइंग वर्क, इफ वर्क डन इज देयर, देन देयर इज 2 चांसेस, पॉजिटिव और नेगेटिव. या तो जिस डायरेक्शन कर रहे हैं उसी में होगा, या तो उसके अपोजिट होगा, और या तो एक कंडीशन क्या हो जाएगी, देयर इज वन मोर कंडीशन, दैट द वर्क विल नॉट बी डन. when the work will be done, when the work will not be done, or when the work will be negative. That all we have to understand. So let's begin with the positive. So in positive work, simple thing we have to understand that suppose that I am giving you a condition. चलो सबको एक एक काम दिया, तुम लोग का वेट कितना है, चलो अब इसको कमेंट मत कर देना कितना है वेट, अपना वेट अपने पास रखना, मुझे नहीं चाहिए. Suppose that I am taking that your weight is X, okay, X kg, mass, weight, जो भी समझना है, and I have told you to drag a wall. There is a cliff, या हाँ cliff मान लो, ऐसे बनता है ना पहाड़, like that, यहाँ से रिवर निकलती है, सीनरी बनाते थे ना ऐसे. So suppose that you are standing here, कहाँ पे, यहाँ खड़े हो, या चलो यहाँ नहीं खड़ा करते, ऊंचाई पे हो तुम लोग, ज्यादा गड़बड़ करोगे, यहाँ पे हो. ओके, यू आर स्टैंडिंग हियर विद द मास ऑफ x kg, एंड देयर इज अ रॉक कैन रोल, दैट इज हैविंग द मास ऑफ 4x. अब तुम्हारे मास से इसका 4 गुना जाता है, कितना, 4, 4x. नाउ देयर इज अ रोप, एक रस्सी बनाई और ये पकड़ा दी, पकड़ लिया, छोड़ना नहीं. Now what you have to do, you have to drag it towards yourself. इसको क्या करना है, इसको तुम्हें अपनी तरफ खींचना. You will apply force, you will apply or not. नहीं अप्लाई करोगे मार खाओगे. काम कहाँ है, काम करो. So you'll have to apply force and you'll have to drag it. So when you will drag it, is it possible for you to take it out upside? ये possible है तुम्हारे लिए कि इसको तुम अपनी तरफ खींचोगे. Simple thing is there. Your mass is x kg. Suppose that your mass is 10 kg and you have to drag the weight of 40 kg. 4x, that means 4 into 10. 4 into 10, that is 40 kg. It is possible for you to drag if you are not a bodybuilder. अब ये मत बताना कि हाँ सर हम बॉडी बिल्डर हैं, उठा लेंगे 40 का 80 kg भी उठा लेंगे. So actually when you are dragging it, what will happen, this rock will go downwards. It will come downwards, not towards this. इधर नहीं जाएगा, ये उल्टा आ जाएगा. But force किधर लगा? Force you have applied to your side. So when the force is applied to the negative of the displacement, or you can say when the force is applied, when the displacement is done negative to the direction of force. When the displacement is done negative towards the force, yeah, opposite to the direction of force. Suppose that force was applied in this direction, but the displacement had done in this direction. Then what will happen? Then there is chance that it would be negative. The work done will be negative. Work done will be there, but this will be in negative. This work done will be negative work. Okay. Now, suppose that again same thing. Okay. यहाँ से नदी निकाल दो. फिर यहाँ खड़े हो. Now this time you are having the mass of 4x. You are having the mass of 4x, mass of the students, and there is a rock, chotu sa, and it is having a mass of x. Now your weight is 40 kg and the weight of the rock is 10 kg. So what will happen? Will you drag it? Simple, sir. इसको तो एकदम हलवा है, उठा के फेंक देंगे. So like that, when you are dragging it to this direction, the rock will not go this side. इस side नहीं जाएगा. It will go towards the direction in which the force is applied. So in which the force is applied, so we can write it as it. Force is applied to this direction, and the displacement of the object is also in the same direction. So what we can say, when the displacement of the object is done in the same direction of the force applied, that will be called positive work. What will be called? That will be called positive work. Okay? चलो आगे चलते हैं. So when we are going आगे, then there will be 0. So why it will be 0? Because we have not gone आगे. Look, I am telling that we have to go forward, but I am standing here. So is there any work done? No, simple, 0. We have understood that W is equal to F into S. Either F is 0, or S is 0. If any of the condition is having 0, then work done will be 0. Like that I have given you example of wall. क्या दिया था example? कि दीवार है, उस पर जाकर जोर से ताकत लगाना, जितना खाए पियो, महीने भर साल भर में जितना खाए हो उतना खा के उस पर ताकत लगाना. If you will push it, then what will happen? Will you be able to shift the wall an inch? 1 inch भी खिसका पाओगे? नहीं. So if you are applying a force of 5,000 Newton, or 15,000 Newton, 50,000 Newton, जितना लगाना लगा लेना, and the displacement is 0. So what will be the answer? I hope इतना मैथ तो आती ही होगी. If 15,000 into 0 is equal to 0. So what will be the work done? The work done will be 0. So this was the type of forces. Then after next topic that we have to understand is about energy, and that kinetic energy, potential energy, and some other topics that we have to include. Before that, you have to tell that all the points that I have told you is all these points are understood to you or not. Let me check that have you commented or not. Okay. So I hope these points are clear. So for the next class, we'll meet on the next day. Thank you.